Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. My dear students at Rital International Academy, 11th and 12th grade. Regarding the worksheet I uploaded to you in our classwork, I will solve the questions from 4 to 8. I already solved questions from 1 to 3 on a previous video. Here I will solve question from 4 to 8, which is about DC circuit. This is the questions number 4. The question number 4. They give us this question: what current flow through the 4 ohm resistor? They ask us about the 4 ohm resistors. Calculate the current here. Look here, I will measure it here by this simulation directly. It is 2 ohms. This is how we measure it in simulation applet, but we have to calculate it on exam. If we have such this question, we have to solve it in exam by some laws we will follow it. At first, we will try to simplify the circuit. Whenever you have this diagram for a circuit, we're trying to simplify it and to make it a single resistor. We have many resistors here. We have 2 ohm, 2 ohm, and 4 ohm. So we must simplify it. And I have to look at the circuit elements in parallel and on series. Now they are in parallel here. We have 2 ohm and 2 ohm in series. So the 2 resistor components are on parallel here, 2 ohm and 2 ohm. So this is the rule of simplification of resistors in parallel. 1 over total resistance is equal 1 over R1 plus 1 over R2. If I have more resistor component, I'm going to add them. But this is enough for us in this case. 1 over total resistor, 1 over 2 plus 1 over 2. The invert for each resistor, 1 over 2 plus 1 over 2. It's 2 over 2, which is equal 1. If you invert it, you will get total resistance equal 1 ohm. So the total resistance here is equal 1 ohm. It's become this way, 1 ohm. So now I simplify it from 2 elements. It's become 1 element only, 1 ohm. This is how the circuit looks after we simplify it. Now the resistor in series. Okay, I have this element and this element. They are in series. They are not in parallel. In series, I'm going to add them directly without make an inversion for them. I don't have to invert them. So now 1 plus 4 gives us 5 ohms. It is 5 ohms. Now the resistors become this way, 5 ohms. Okay, be aware here. If you put the resistors here or here, there is no difference. Now it's become 5 ohms. Now it is a single resistor. Now I'm able to solve it. Now we can use Ohm's law. V equal IR. I have the V, 10 volt. I have the total R, 5 ohm. I need the current. 10 volt equal I times 5 ohm. Divide each side by 5. Solve for I over 5 over 5. Sorry. Current equal 2 over 5, which is 2 ampere. It is a current. So now we solve the questions. The question number 4. We end up with it. We show that it's the same value we got when we use simulation. But in the exam, we have to follow this rule by solving it mathematically. Now, what is the voltage drop across the 4 ohm resistor? Here, they ask us about this resistor 4 ohm. Look, in simulation, we could calculate it. The voltage drop on 4 ohm resistor, it is 8 volt. But now we have to calculate it mathematically. Here we calculate it directly by use voltmeter. So we must use mathematics to calculate it. since we calculate the current through the whole circuit, which is 2 amp, as we calculated in previous question, we could use the current we calculated directly. 2 times 4, it is 4 ohms. 2 times 4 give us 8 volt. It's a direct question. Be aware here, if you were wrong on question 4, be sure you will be wrong in question 5. Okay, question number 6. How much heat is generated in the 4 ohm resistor in 2 seconds? Question asking us about heat, and we have to know what do we mean by heat. Heat is an energy. If you study physics well, you must understand that heat is an energy. And we use in this case Joule's law. Joule's law, I squared times R times T. We denote T as a time. Be sure to make time in seconds. If you have another questions in minutes or in hours, you have to convert it to seconds to make sure your answer will be right. So I squared, we calculate the current to 2 squared. We know the resistance here is 4 ohm. They ask us about 4 ohm times 2. 2 squared, 4 times 4, 16. 16 times 2, 32 joules. This is the heat generated by the 4 ohm resistor. Here I squared times R, it is an energy. If you use any other type of energy, V squared over R, you must have the same answer. If you use IV, you must get the same answer. If you used V squared here, 8 squared over R, 8 squared over 4, 64 over 4, 16. 16 times 2, make 2, you will get 32 joules. If you use another one, here we used V squared over R. I'm sorry for this. V squared over R. We replaced by I squared R. And we could use I, V, also for energy, IV. If you calculate IV, the current to the voltage drop is 8, 2 times 8, 16, and multiply it at the end of it by 2 seconds, you will get 32 joules. Now we get all the way to our answer. Questions number 7. How much power is dissipated in the 4 ohm resistor each second? Okay, they ask us about the power here. In each second, that means they ask us about its value directly. P equal I squared R or V squared over R or IV. Any one of them will give you the answer. We used I squared times R, 2 squared times 4, which is equal 16 watt. If you used V squared, 8 squared over 4 will give us 16. If you used 8 times 2, you will get a 16 watt. Any one of them will give you the right answer. Question 8. What is the voltage drop across the 2 ohm resistors above? They ask us about this one here, or this one. Does that gonna make a difference? This one or this one? Let us see. We have to know the total voltage drop across the whole circuit equal V total voltage equal V1 and 2, V1 and 2 because they are in parallel. We have to know that, plus V3. We know V total is 10 volt. We calculate V3, which is in 4 ohm, which was 8 volt. 8 volt equal V12 plus 8 volt. Subtract 8 volt from each side. You will get 2 volt. So V12 equal 2 volt. And we use this information. Parallel resistors have the same voltage drop. This drop voltage in this one equal to this one. 2 volt will not go into distribute in each resistors, as we see here. We have to know this rule. It's a golden rule for us. So V12 equal 2 volt, and the parallel resistor have the same voltage drop, so the V1 equal 2 volt. By using the simulation, we have this voltmeter. We calculate voltage directly here between two terminals and 2 volt, as you see here. If I put it in a single resistor here, from here to here, the drop is 2 volt. Be sure that here too, what we're asking for, it's above resistors, would be 2 volt. So physics work in this case. Thank you, everyone. I hope you will remain safe and unharmed in your home. Goodbye.